What that I am here today for is to make you all aware of where composites are used in America now, where they can be. I want to make you all composites experts, so to speak. This is just one example of a composite. This is actually what's called a 1-inch eye-bar. It's grating. A lot of people, every day you'll see some metal grating. Well, this is a fiberglass, a piece of fiberglass grating, but it's also what's inside that I'm pointing out here. What gives it the strength is the fiber reinforcement itself. This is called the fiberglass. These strands give it longitudinal strength. What you see here is called a mat that gives it a transverse strength. This is that surfacing veil that I was referring to that makes it very resin-rich and smooth. And on the very outside of it, the yellow part, that is the resin, which gives it the chemical and physical properties to make it do what it is that it's going to do. So you've got a combination of what makes it strong and a combination of what's going to give it its physical properties. Thank you, John. Now, how is it different than steel, aluminum, and wood? Well, these are the features of it. It's going to be both strong and lightweight. To make it simple, it's going to be about 80% the strength of steel, but only 20% the weight. But unlike steel, it's also going to be very corrosion resistant. So in the presence of some ugly chemicals and things like that, it's not going to rust, rot, or corrode. It's also going to be very low or non-existent when it comes to conductivity, both thermally as well as electrically. Where are composites used? I'm going to go through several slides because you've probably come into contact with composites every day and you don't necessarily know it. Certainly in aircraft, both commercial as well as military. The appliances, both household and offices, power tools like what you see there, but I wouldn't be surprised with what you have at your home, a ladder. It's probably a fiberglass ladder. In the architectural and construction industry, you may have taken a shower this morning in a composite shower stall, like what you see at the very top. Over on the left, while you see what's becoming more and more commonplace today, and that's to put in green roofs. And then over on the bottom right, they had to put some really strong antennas in there. There were 20 of them in there. So they had to have a material that was going to allow all of the radio waves to, again, pass back and forth unimpeded. Certainly in the automotive industry, for quite a while, many parts have been used in that industry to make things more lightweight, which translates into better fuel efficiency. And if you are a golfer, your shafts may very well be composite. In the center, while you'll see furniture, which is going to be impervious to rain. It's not going to rust or rot or corrode the way that other materials will. And a lot of times in umbrellas, the shafts of the umbrellas today, to make them much more lightweight, a composite material is being used. One of the primary reasons that a lot of composites are used has to do with corrosion-resistant areas. So in order to keep the acids and caustics and things like that contained, they'll often be stored on top of what's no longer metal grating, but some fiberglass grating like you see on the right, on the left. And then over on the right, while there are silos and tanks that will house a lot of those acids and things, so it will last much longer than what a metal structure would be. In the electrical market, what you see on the left is an oil containment device. This is in a substation, and these are being used all throughout America now. And we're going to talk some more about what you see on the right with the utility poles. The energy turbine blades oftentimes are going to be made out of a composite material for lightweight so that it can be used very efficiently. Next. In the marine industry, if you own a boat, more than likely that boat is going to have a composite hull, as well as what you see on the right. You'll see what is described as a stealth ship. And we've already talked about trains, planes, and automobiles. So what you see obviously on the left are in the transportation industry. The trains and third rail covers is what that I'm showing over on the right, which you'll see if you're using Metro. Take a look the next time that you are near the train tracks, and you'll see a cover. Okay, the reason that we're here today is to talk specifically about the infrastructure market. And so what I'm going to talk about now will be to show you some examples of where the composites are used in the wastewater industry, the utility and communication, bridge, and rebar markets. So to start with the wastewater treatment market. In wastewater, there's a lot of really ugly chemicals that are used that make it just very difficult for steel, aluminum, and wood to exist. This happens to be a support for a 54-inch diameter pipe. Now, even though that big support there is as big as what it is, it's only going to weigh about 20% what a steel support would be weighing. That pipe, however, when it's full, it will weigh over 21,000 pounds. Grating is a product that is often used in wastewater. This happens to be a raised floor system so that the people can get down below. A baffle in the wastewater market is used to direct the flow and the speed of the water. What you're looking at there proves its durability. Over on the right, you see what it looked like when it was installed in 2002. On the left, you see a larger snapshot of what it looked like 6 years later in 2008. As neighborhoods continue to evolve and grow and more neighborhoods are developed, they get closer and closer to what used to be a remote location for a existing wastewater treatment plant. And one of the things that is going to be a concern is the odor control. So composites will answer the need for maintaining odor control in existing wastewater treatment plants so that is not smelled by the neighboring communities. Okay, now we'll move on to another very good application for composites, which is the utility pole market. Right now, this market is dominated by wood and concrete poles and steel poles. Well, the wood poles, as soon as you put them in, they start to rot, so the clock starts ticking. And then you have concrete poles, which are extremely heavy. And then you have steel poles, which not only are they extremely heavy, but they're also conductive. With a composite pole, they are not only durable and maintenance-free, but they're going to be very strong yet very lightweight, and as opposed particularly to the wooden poles, which once they have to be taken down, they're actually considered to be a hazardous material at that point. You do not have environmental and toxic concerns with composite utility poles. This is a shot of composite poles being used in a sports arena. Another major advantage to a composite pole is that you're going to save a lot of money transporting them from point A to point B. Also, they're going to be able to be much more easily installed. A concrete pole is very difficult to install because it is so heavy. And we can't forget that many times these poles are going into areas where trucks cannot get to. We're getting into the time of the year where this has to be a concern. When we have freezing rain you start having power poles snap. Composite poles are much more resistant to that because they have elasticity. Next is the bridge market, and let me say that it was a few years ago that the Department of Commerce teamed up with the company that I work for, because they said that if the government replaced all of the bridges throughout America that needed to be replaced because of corrosion and the fact that they were weakened, that the government would have to spend $1 trillion to make it happen. They wanted to know if there was a product like a composite material that could be used in the place of steel, but through their help and some resources of Strongwell's, a composite material was developed that was going to be durable, resistant to salt corrosion, because the reason that most of our nation's bridges become weakened to begin with is because of the steel members, the steel girders, becoming corroded. But yet the product still has to be very strong and lightweight. The product that the government and Strongwell developed is this composite beam, like what you see on the right. It's being tested right now. It's a 36-inch I-beam, and it is a direct replacement for a steel girder. This is everything you're looking at there in green is a all-composite bridge. It's down in Barbados. They needed something that was going to be corrosion resistant because there's a lot of salt water all around it. In Tangier Island, it's a very remote location. In order to access the island, there was a wooden bridge there. So they wanted to replace it with something that was going to be going to last for many years. So they decided that they would use a composite deck material. This is Knickerbocker Bridge up in Maine, and what you see over on the right, kind of on the top of the right, those are box beams that are used as the support for the bridge that you see on the left. Not very far from here in Vienna is this Wolf Trap National Park. The deck itself is an all-composite. It's very lightweight, and one interesting thing is this bridge is in 3 spans, and it was so easy to install it that the lanes only per span, the lanes only had to be closed for 15 minutes per span. And lastly, I'll talk about rebar. Do y'all know, I guess most of you know what rebar is. Rebar is used in concrete specifically to give the concrete some additional tensile strength. And rebar historically has been metal. We've talked about what the problems are with metal and corrosion and things like that. Well, as opposed to that metal rebar, composite rebar is going to be non-corrosive, it's going to be impervious to salt, it's going to give the concrete an increased service life, and it's going to be much more lightweight. I'm just going to show you some examples, some shots of where the composite rebars have been used. This is the first one that was in West Virginia. Here is the rebar being tied off the way all rebar needs to be in Iowa. Next. This is in this is another shot of composite rebar being used in a decking situation. Next. Here it is in Utah. Next. And it's used both in the United States as well as Canada and other places. This is just a shot of a bridge deck in Canada. And I think, yeah, here's another one in Kansas City, and one of my last ones is another one that's in Canada as well. So, to summarize, the benefits of composites in infrastructure is it's going to be strong yet lightweight, but it's going to be impervious to corrosion. It's going to be around for the long haul. It's going to be very durable. I know at my company, we market it as a permanent solution. It's not going to be anything that will rust, rot, or corrode. And lastly, the low conductivity, both thermally as well as electrically. Thank you very much. Are there any questions? We appreciate your all's time.